Jewish.
If you go back and look at World War II, they would leave the dad behind and take the mom and the kid because he was
The Jewishness?
yes, but if it was just the dad, they would only take the dad.
Jewish descent goes through mom. It's passed through.
Yeah, typically they would
So,
take
like,
the mom and the
your
kid
mom
or just the dad.
wasn't Jewish, but your dad was Jewish, you're not Jewish. But if your mom is Jewish and your dad isn't Jewish, then
Then you're a first generation Jew, and your kids, and if you're a girl, your kid will be second generation Jew.
Huh. Yeah, interesting.
Jews. Okay, that wasn't meant to
It
be
didn't
like,
sound right. It did not sound right.
that wasn't meant to be like a go
Your hand gesture might have to.
Yeah,
Had to be
I
careful.
noticed it afterwards.
When you raise your hand like that while saying Jews did.
I made mistakes, okay? Here, I'll do a whole YouTube apology video.
All right. Cancel Logan. All right, so let's just review everything that we have covered so far. So far that we did not test it those amount of material. So let's review a little bit about what kind of things that we have covered that we didn't test yet, and it will be on the next test. So.
Mr. Ye, we can see some like really pretty clips, but we can't see you.
Pretty clips. Okay, so.
it looks like the K's and clips update on Minecraft. Right?
I think the clips are actually based off of
Really? They stole that from Minecraft?
that's from Minecraft.
That's all from Minecraft? That's so sick.
I should have read that.
Nicole, can you help me close the window because it's too loud outside.
Ambient noise.
I like that.
How much space have we?
Not really.
It is very ambient.
I don't think locking it before it's in place is gonna do the trick.
Does she know how to work a window?
Okay, just push hard, and then they will come back. Yeah.
Push it so it doesn't get
That's a nice
caught.
beat, okay. Hey.
No, push.
These are
It's
the other one.
I wonder who said that.
Oh, there you go.
All right. So, shout out to birthday boy Connor. So what we're gonna talk about we already talked about certain things that Elhabdo Rule. So Elhabdo. And no, this is all the stuff we covered so far that have not tested yet. So I want to kind of go back, review a little bit. Elhabdo Rule is derivative of the numerator and derivative of the denominator. If it doesn't have it, you want to make it happen. Okay? Or sometimes you want to, there is a few indeterminate form, right? So there was 0 over 0, there was infinity over infinity, and there are 0 times infinity, and there is a 1 to infinity power, and there is a 0 to the 0 power, 0 times 0 to the 0 power, and there is infinity minus infinity. So somehow you're gonna make a numerator and denominator, and you take a derivative top and bottom, and you try to reach that limit again, and then if it doesn't work, you're gonna take a derivative again and try to reach again. So until it works. Okay, and sometimes you might have to deal with natural log of both sides. So sometimes, right? Sometimes you need a natural log both sides. If you look at the notes, so for example, let's say it's x to the x power, like y equal to x to the x. So say limit x approach to 0 of x to the x power. That's a 0 to the 0 power. But really cannot do that. You have to set this is equal to y, and you natural log both sides, and then things happen. So, or you had to make a numerator and denominator, right? So those are the first thing that we cover for Elhabdo Rule. What else we did not test? Arc length. Nobody remember the equation? Equation is really easy. Integration between a to b, square root of 1 plus f prime of x squared dx. You have arc length. Now, I did not cover shell method because I already covered this in washer. So I choose to skip shell because we don't have enough time and they don't test it. So we're not gonna worry about shell method. So we skipped shell method because we have covered, we test disk and washer. Okay. So we covered the integration by parts. We're gonna talk about a lot of integration technique from now on until we got enough and technique. Right? Integration. Oh, sorry. Integration by parts. Sorry, by parts. And this L-I-A-T-E. L stands for natural log. This stands for I. What's it, I stand for? Inverse trig. Right? A stands for algebra. And T stands for trig. And E stands for e to the x. And yesterday we talked about L-I-A-T-E, that's what you're going to sub as u. As u. Or the DI method. Or the DI method. So you're going to use that as a D or I. So if you use a DI method, when do you stop?
Constant or integratable or what was the third one? When it's the same as the original.
So when to stop, right? When to stop the DI, right? When to stop the DY, so when is a constant, which is, this is the most beautiful one, constant at D, or it's integrable with D and I. The last one is what? Same as the question. Same as original, right? Same as original. So, and I think DI method is much easier. But don't forget. So what people usually forget, what do you think they usually forget?
The same as original.
No. When I do DI method.
Oh, the
Plus
plus
minus.
The plus minus signs. The alternate sign, right? So you have to have a plus, minus, plus, and DI. So make sure you have plus, minus, and keep on going. So sometimes you might have to do it a few times. So knowing when to stop. And especially same as the original usually happen at T and E. So only when it becomes T and E, then like sine of x and cosine, sine of x e to the x, or sine of x e to the negative 3x, you had to move back and then you divide.
Can you do all questions by either subbing U or DI? Like
What?
it doesn't matter which method you choose.
Can you say that again?
Like, does DI do both DI and subbing as U work for all of the questions?
DI method only if, so DI method is only if it's a part question. It's like integration by part question, which is, so what is integration by part question? For example, a couple weird example would be like natural log of x, right? Or arc sine of x. So arc sine of x, like inverse trig. So inverse trig or natural log by itself. Is the only time used by parts, but with the regular U substitution, you cannot use DI. I don't know if that's a question you're asking. The regular U substitution, you cannot use a DI method. But I don't think I answered your question. Can you rephrase your question?
I'm saying like, for if it's a question like that you can integrate by parts, can you use both subbing U and DI for that question? Or is there other specific like circumstances for integration by parts where you have to use only DI?
Well, most of the time I would prefer use DI. By parts, just because I have to start teaching by parts first. DI is laid down, they find out a shorter way to do it. Most mathematicians in the past always been using a DI method, using integration by parts. But until DI kind of invented, DI kind of come up with it, then they kind of just stick with DI and knowing when to stop. That's the thing. So I will probably preference, if anything by parts, I will use DI. Okay. Now, maybe natural log of x. Right? Well, natural log of x, can you do DI? Yeah, you still can. You still can, really, technically. In arcsine, you still can, but it does not. You probably use DI, it would be make more sense. But so the LIATE. Now, what other technique there is? But I want to review something that students when they understand that certain situations. So remember that integration. There are two special places that that is U substitutions, right? So usually is the du is present in the questions. So U substitution, which is most of the time you have to recognize. U sub is once you take a du, right? Once you take du, that is within the questions. Do you see what I mean? Like for example, U substitution, I know that 2x squared plus 4 to the 10th power, and this is 4x. Because du of this, or the same degree, right? Du of this is 4x, that is there. That's when you use U substitution. When do you use the back sub, right? So back sub is, when the back sub is what? If the same degree. Like, if the same degree inside, so same. That's the back sub. We guys know what is back sub, right? Do I need to review that? No. Or like this, like example, like natural log of x over x. Why? Because you said u equal to natural log, then it's going to be 1 over x. So it's within the question. So you see, if you take you the first thing you think about U substitution is, if I do u, what is a du? Is du within the questions? Does that make sense? Right? Does that make sense? Okay, so those are the things that you should think about U substitution. Now, when do you do natural log integration? Natural log integration. What is the key for understanding natural log integration?
Isn't it when there's
1 over x?
1 over x, but why is 1 over x? Because you see that, I'm going to give you a different situation than 1 over x. That just says 4x squared over, I don't know, 4x to the third minus 3. This one is natural log. Why is that?
because the degree on the bottom one is the one above the degree on top.
Yeah, so you see that degree is one less. So if it doesn't have to be the same number. So if you got, let's say, you think about it, u equal to 12, u equal to 4x to the third minus 3, du is equal to 12x squared dx. So you see that x squared can cancel out, so you know that's a U substitution. about U substitution with the natural log, right?
Yeah.
Now, there's one more that we learned is inverse trick is follow certain formats. And this format is like integration of, I don't know, 1 plus 4x squared. Those are arc what?
That's our tangent.
Arc 10, right?
Yeah.
And there's an arc sine, right? Arc sine would be square root what?
1 over square root 1 plus x squared.
1 minus
1 minus x squared.
x squared. So those are the arc sine situations.
Then our cosine is just.
Isn't cosine just negative sine? The whole thing?
Yeah, it's a negative. So what happened is this. If you have those two situations, it's inverse trig. This is the arc 10. And this is the arc sine, right? But if I have this as an x, then it's what?
Then it's natural log, right?
Actually, it's not natural log. Because this is square root.
So just use substitution.
It's just a U substitution.
Okay.
Right? Now, so literally like there's
The u substitution that would just be 1 minus x squared, not square root 1 minus x squared, right?
no, if I have this as x, right?
Yeah.
The U substitution will cancel out, and you just have the square root of integration of square root of U. And so those are all the things that can happen systematically. There was a long division, right? So when do you use long division?
Can you go, okay, for the arc tan thing, is the 4 impacted at all? The fact that it's a 1 plus 4 squared? Or,
It's just 1 plus x squared. I'm pretty sure, right?
U is equal to 2x. Then you have to go back and remember what's the arc10 formula.
I knew the arc tan formula, I just didn't know.
Okay, so you have to know when to use what, right? All those things, all of them, if I give you all 10 questions, all different, then you have to figure out, you have to sift through when to use. Long division is when numerator is greater than degree-wise, right? Degree-wise is greater than, more likely greater than the denominator degree. So that you had to use long division. You had to long divide it out. So there was a lot of things involved when to use backsub, when to use natural log, when to use inverse, when to use long division. Right? And there was a couple special tricks that's what we're going to introduce. And also there was the sine and the cosine. So we're going to talk about some stuff that when to do that. So sometimes you can also break up too. So you can break up as well. So breakup is like this. Integration of x plus 3 is equal to square root 4 minus x squared. So if you break up this, how would I break it up? Just x over square root 4 minus x squared.
Oh yeah, and then plus 3 over.
Plus integration of 3 over square root 4 minus x squared. So what is the u sub? What is the integrations here?
U sub.
That's the u sub. What's integration for this one?
That's you can do inverse trig on that,
Yeah,
right?
but you could just take the 3 out.
What is that?
You just take the 3
Yeah, you
out.
just take the 3 out and
and
you can
just
do inverse
integrate.
trig.
But what is that? What is integrate of this part?
R10.
No.
Sine.
Wait, what?
Arc sine.
Arc sine.
R9, oh, I'm stupid. I don't know how to read.
Yes, you are stupid. You are.
Okay, I'll do this one.
Okay.
So does that make sense?
Yeah.
So sometimes if this is two terms, you can break them apart just like normally you would to be able to do. So a lot of situation you have to think about knowing when to use what. So I'm gonna give you a comparison of 3 examples. This is a one of them, and there's another one. So we're gonna kind of give you all the things that can happen. So I'm not gonna do them. I'm gonna just tell you what happened. So what's the integration of 4 over 9 plus x squared plus 9? We don't have to do them. Just tell me what kind of integration is this.
R10.
Arc 10? Okay, so this is arc 10. What's integration of 4x over x squared plus 9?
That's next law, right? Or break.
It's actually both, right?
Yeah.
Because this one doesn't have a square root. So you compare this one and this one. This one just only use substitution. But this is 1 degree less. So this is a u sub and what?
Natural law.
And natural log. How about this one? We never talk about this one.
What does that say? X squared plus 9? You break it apart and then do.
You can break apart, not 4 plus x squared,
Oh, sorry. So that would be long division then, right?
long division. So if you long divide it out, this will actually end up to be equal to integration of 4 minus 36 over x squared plus 9. So it's actually just a normal integration of 4 and there's arc10. So each situation, even though they are look almost similar to each other, but each thing is kind of different. Is this confusing?
No.
Just kind of review all the things that can happen. And there's a difference between this one and this one. Why? Because one is u sub in natural log and one just u sub. Do you see the layer difference?
Yes.
Okay, so we just talk about, so like if you go to a very good college, they actually have a math competition. Like instead of spelling bee, in like MIT they have actually integration bee. So they just give you all kind of integration. You had to figure out which integration is supposed to be long, and you had to do it really fast in 20 seconds. Stanford has it, MIT has it, Harvard has it, but that's only if you're a mathematician. Of course, you can major in poli-sci, then that doesn't make any difference. Huh? No downgrade on poli-sci. It's just like that just not something you don't want to go to MIT and go to poli-sci. Doesn't make sense. It's not logical. So breakup, I'll show you color separate, right? Separate. So you can break up things and integrate both. We also talk about completing the square. Is anything completing the square? Do you guys remember completing the square?
I do.
Completing the square usually on arc 10. Usually on arc 10 that you can complete a square. You can make it 2 parentheses, they subtract each other, and that becomes arc 10. Now, I'm going to show you one more interesting things that is a disguise of log rule. Now, this question will never show, but it's nonetheless, it's actually pretty interesting. It's a very cool trick that you guys got to be able to see, and I want to show you this one because of 1 plus e to the x. I'm going to show you a trick, right? A trick to do integration of this. Now, what can I do with the, what's your first idea?
Rip the paper. Give
I'd
up.
say bring the 1 plus e to the x up if possible.
Maybe.
You cannot do that.
U sub e to the x
Sub
equals
e,
e.
But the problem is, what is a du?
e to the x.
Do you have e to the x present in the questions?
You live in one
So you cannot do u sub. See, do you guys see why now? Like you have to be able to recognize all those things. You cannot use u sub.
Natural log.
You cannot natural log of this. That doesn't get rid of e to the x because it's 1 plus e to the x.
I would say arc10, but that just doesn't make sense.
Arc10 might be a.
Arc10 is the only one that makes sense besides those two.
Arc10 is actually doable. Arc10 is actually doable. But no, it's not doable because u is going to be e to the square root of x, or e to the x to the either square root of x, or square root of x times square root of x is equal to x. So you can do that, but the problem du is not present.
But why would we need du?
You still need a du for arc10.
I hate this.
Okay, so I'm gonna be patient with me. I'm gonna show you something that's actually pretty interesting. It's pretty cool. So this is a cool trick. So you can integrate something. You can have to foresee this, and not all the time people can foresee this. Plus e to the x minus e to the x.
Oh, and then you can do like u sub and arctan because now there's e to the x's.
No.
No. Once. So then what's the point of doing the?
Oh,
Integration.
then we can take the substitution.
Well, sort of. But before you do that, you break up to two separate integral.
And then one becomes one.
Oh, yeah, one becomes one, and the other one you could use substitution.
So they are disguised. A lot of time, normally people don't able to see that. It's like seeing chess move like 3 steps ahead. You see, okay, that's, oh yeah, I can manipulate that way to favor of you. And that's one of the trick. And now this is going to be U substitution. I'm not going to finish that up. You guys know how to do integration to 1, hopefully. Jonathan's like, challenge accepted.
I can do that.
You cannot do that. Okay.
Wow, Mr. Yes.
It's
The
two.
integration of one is like those math
It's two,
competition
let's move on.
questions.
Integration of 1.
That's not math competition.
That's a math competition question.
Math competition.
Okay, so do you see that there is a difference between all the technique, and you have to be able to utilize one. So I remember in college chemistry class, you're gonna have they give you some type of unknown, right? And they say, okay, I want you to. They will teach you all different kind of tests, like nitrate tests, copper tests, flame tests, and all different, like 10, 20 different tests. If you take an AP Chem, you probably remember, like flame test for copper. Copper is going to show up which color? Do you guys remember? Green, right? So copper is going to show up green, and you're gonna. There's a chloride test. How do you test if something is chloride? You probably did. You add a solution with sodium nitrate. Silver nitrate. Because silver and chloride is going to form a participations. Do you guys remember that? Yeah, because silver and chloride is going to form, but silver nitrate is clear, but silver chloride. So you have to know all the tests, and then if you know all the tests, they give you a no, right? So for example, I give you integration, and then you have to figure out which one I should do best. Now, can sometimes some situation, the two situations gonna fit? Yes, sometimes. But most of the time, there's the most efficient method. This is probably the only way that you can think of that right now. But they probably like 10 other ways to do it. But this is probably the easiest way. Okay. Now again, I'm not very expertly at calculus 2, but there was a lot of tricks that there was expanding, there was the completing square, dividing proper fractions, adding, subtracting, so all those things. So those are the things that you might see, and you have to knowing when to adopt. Now, what we're gonna teach today is trick integral, specifically trick. So we're gonna talk about this: sine to the third x, cosine to the fourth x dx. Now I'm gonna tell you. This is applying trick and U sub. And trick, the most popular trick identity is what? The most popular trick identity is what? Okay, good. So with that and the U substitution, you can solve this problem, believe it or not.
Is that cosine to the fourth?
Yes.
Okay.
It's not by parts. Because they're both trick. It's T and T.
Okay.
It's not T and E.
Yeah, u sub and then.
Let me just ask a question before you start that. Do you know how to do this question?
What is that? I can't read. Sine 5x cosine x?
Do you know how to do this question?
You take
I believe so. Cosine x equals u, and then
you substitution.
No.
Sine 5x equals u then. One of them equals u.
Why? Which one? What? Remember, why do you do use substitution? Why do you do use substitution? Ask yourself, why do you use substitution? So you're hoping something will cancel out, right? So u has to be what?
Sine.
So u has to be sine of x. Du is what? Cosine of x dx. And you see this part is already cosine of x. That's just integration u to the 5. Du. Does that make sense?
Yes.
And that's going to be u6 over 6 plus c. And then I'm not going to finish this part, but I just rewrite it as a sine to the 6th power over 6. Now, the trick is to make that happen, right? To make that happen. So let's think about it. Can I break this one up to sine square of x times sine of x times cosine to the 4th x? I do it slow motion. And there was a reason why I do slow motion. What is sine square? What is sine square?
1 minus cosine squared.
Oh.
1 minus cosine square. 1 minus cosine square, right?
Yes.
Cosine to the 4th x
Sine x.
and sine of x, right? What does u has to be here? Well, you probably had to do something else before you see u. Remember, u has to equal to something. That u is what? There we go. So now you're just gonna start getting. So this one's gonna be 1 minus u squared times u to the 4th, and u equal to cosine of x.
Yeah.
Du is equal to what?
Sine of x.
No.
Negative sine of x.
Negative sine of x dx. So therefore, this part is going to give you a negative sign. Does that make sense?
Yep.
Wait.
Because this one is this one, right? Du, right? I can move the sine of x to cancel out, but it's still going to give me negative. And then
Derivative of cosine of negative sine.
integration, this one's going to be, I can actually that's going to be u to the 4th minus u to the what? 6 du. Now, can I take an integration to this one? You can do u to the 6 minus u to the 4 du. Becomes very easy integration. Does that make sense? Sine x to the 7 over 7 minus sine of x.
That'd be cosine of x, right?
Oh, cosine of x, you're right. Cosine of x is 7. And this one is going to be what?
Cosine of x to the
5 over 5 plus c. Does that make sense? U equal to something is going to help you solve the problem. You had to foresee what is u. I cannot teach you this. It's just by experience. I don't know how to do it, but just by experience that you see this thing happening, and that's what's going to be.
You can't combine the u's. Like you can't simplify that.
Which one?
Like u to the 6 minus u to the 4th, like that's not u squared, right?
No,
Or
so
you
they're
know
not
that.
dividing.
Yeah.
That's puppy killing.
They have to be dividing. in
No.
order to do that.
That's puppy killing right there.
Okay, I was just asking.
Yeah.
I will pretend I didn't hear that, but no, you cannot subtract that because they're different power. If they're both u to the 6, then yeah. I say u to the 5, u to the 6. If you should think about it, if we change it to x, does that make sense? X to the 6 minus x to the 4th is equal to x to the 2nd. Only if it's u to the 6 over u to the 4th, then that's going to get u to the 2nd.
So if they did have the same power, you could simplify it?
Of course, if you have 5u to the 6 minus u to the 6, then it's going to be 4u to the 6.
Okay.
So. Got it? Does this make sense?
Yes, sir.
Yes, sir.
Okay. So, you want to try one?
No.
Yes.
No.
No.
Can we go? Yeah.
Why would you want it?
Yes.
Okay.
Nerd, let's bully this nerd now.
Is that
Aw,
secret?
come
It
on.
went-
Oh, come on, okay.
I wanted to try it, but I didn't want to do this.
Get to the fourth 3x. Ah, come on.
Oh, wait, you can do it.
You have to do some manipulations.
Like how John manipulates me all the time.
Yes.
John doesn't manipulate you.
I'm very manipulative, Mr. Head. You just don't understand.
Wow.
You're willing to get manipulated. That's the way to look at it.
He's really hot.
I am.
So I mean, it makes out more. What's your U? What do you
Cosine real.
cosine real?
Yes.
What? Is that like what cosine is sine?
Negative.
Yeah, I was thinking.
Three
I was thinking other.
Three negative.
Yeah, anyways. Wait, why cosine?
Because secant of x.
U equals cosine of x.
3x.
Cosine 3x, and then your du. Which square equals c3.
3.
I know the power rule. Okay, back off.
That's not powerful.
Channel, you know what I meant. You know what I meant. Okay, shut up. Dx. Show dx.
I did put the x.
Better.
So 10 secant times square juice of cosine.
What time we get off?
10 minutes.
I'll give it 3 more minutes.
What? You can finish in 3 minutes?
What the heck, man? Jeez.
So,
You put the negative. You put negative 3 in front.
You mean like,
yes.
so then this would be
U has to equal something. Du is within the questions.
So if I need a 3x.
I did put a timer on Siri. Don't be stupid.
so it's 3
I didn't tell you to do this.
cosine. You won't simplify anything. Because if you continue on your
Yes. So it's du over u.
Remember to utilize the Pythagorean identity. There are 3 different versions of it. Do you know all 3 versions? That's why I asked you guys to give you a test of formula sheet. I said we're going to use it later. And I'm not lying to you.
What formula sheet?
The first we did unit circle and the other side is a formula for all the Pythagoreans.
That, I will try to find that.
Just replace it.
I think I got it.
3x.
So once you bring that up, the 2 just becomes sine 3x.
No, I have all this part. I'm just doing the integration now.
Yeah, it's just the u to the negative. It's just u to the
It's just using the
seven.
No, there's something in front.
Yeah, no, I did something wrong here. I definitely did something wrong here.
Put it,
You can do 6 times 1 is 1. 6 times 1.
negative 10 is 3x. So you have the.
Eva, think about what U equal to.
I think I got
The
it.
derivative is there.
Yeah.
Can I go up so you can check my answer?
Sure.
Oh,
U is equal to what?
3 times it.
I know, I'm just doing the work right now.
Oh, yeah. Is this it?
I don't know.
oh, wait.
No.
No? What did I do wrong then? Okay, Bobby, we're wrong.
You were very close. Let me see.
One over 2. What did we do wrong here? Okay, let's look through the word.
So what's the root of it? U? Don't think so. There's something wrong. I don't know where, but there's something wrong. U is equal to what?
Secant 3x.
Yeah, that's gonna get more messier.
Wait,
Is this the answer?
U is equal to what?
I said tangent squared 3x.
Tangent, no, it would be tangent, not tangent square.
Wait,
And then again,
I don't understand.
plus 1 squared.
Okay, so let me ask you a question. U is equal to secant 3x better, or U is equal to tangent 3x better?
Neither. U equals cosine 3x. I use U equals cosine 3x. Why wouldn't you just use U equals cosine 3x?
Because
Because then secant is just 1 over cosine, and then tangent is sine over cosine. And then,
you have to be right there.
we did it different way.
Let me ask you, which way would it be better? U equal to tan 3x or U equal to secant 3x, and why?
Does it have to be a tangent because it's just the derivative of tangent is just secant versus the derivative of secant is?
Yeah, it gets more messier, one of them, right? So if it gets more messier, one of them, what does du, if I said U equal to this one, du equal to what? Secant square of 3x times 3, right?
Yes.
And dx. And do I have that in the questions? I do, but the problem is, can I break this to secant square 3x times secant square 3x times tangent to the third 3x dx? Now, if this already u, right, then this already part of du already. This is a du already, right? The only thing is I had to change is this. Which is it possible to change?
Yeah.
What is secant equal to?
Square plus 1.
1 plus tangent square of 3x. Does that make sense? And that's going to be, I'm going to rewrite that to tangent of cube 3x. Well, do you see that? I just changed everything to tangent. And then what happened at the end? Secant square 3x dx. Do you see that this, if u is equal to this part, this is going to be du. So that's going to cancel out.
But that would equal like 130, right? Since it's not 3 secant.
Yeah, so that's what I'm going to do that. So I'm going to say dx equal to du over 3 secant square of 3x. So then I'm going to say 1 plus u square, right, times u to the third. Am I doing okay? And I can have those cancel out, so I'm going to get du over 3. So this is 1/3 in the front. So become a simple integral, u to the 3 plus u to the 5 du. And do I need to finish it? You finish it, right? Because the thing is, you had to foresee what happened. There's no way I can teach you all this, like playing chess, right? I suck at chess. I still suck.
When are we gonna 1v1 in chess?
Ooh, can we do that? That'd be fun.
Why wouldn't the cosine way work?
We did at lunch, if you come at lunch.
Why
I went
would
to class during my lunch.
Oh, you have B lunch?
Yeah.
I can do it while we make class.
why wouldn't the cosine way work though, Mr. Ye?
Okay, so let's try cosine. if you do this 1 over cosine to the 4th 3x, right? And the sine to the what?
Sine.
3 to the 3x over cosine of 3 to the 3x. If you do u equal to cosine of x, you have to have one sine on the top. But you have sine cube.
Oh, that's where we messed up.
Oh, okay.
Yeah, we didn't.
You have sine cube. So that doesn't work.
Okay.
So think about what's the most efficient way. You plan it, think about what u equal to do, and kind of plan 3 steps before even writing any down. Kind of think about u is equal to something. What is that result? Is result there for you to take advantage of? I can't really teach you how to do it because you just have to try and error and to try to see what it's going to be. But something had to cancel out, convert everything in terms of u.
Mr. Ye, I did it by u is equals to secant, and the only difference is just the sign. I got u raised to 3 negative u.
So let's try secant. So if I have secant, right? You say u equal to secant to the 3x or secant square?
Secant 3x.
Okay, secant 3x, then you will have a sexy 10. Okay, let's try to plan it out. So if I have u is equal to secant of 3x, and then du is equal to secant 3x tan 3x dx. So I'm gonna write it out with so I think it's doable. Hold on a second. So let me write it out this. Let me write out secant of 3x tan 3x dx. And then if I write it out, this part is going to be secant 3 to the 3x and 10 square of 3x. And then a 10 square of 3x can convert to secant. Yep, I think it's doable.
Yeah, but
I think it's doable. You're going to have a different answer. So, like I said, there's no one way to do it out,
but there should be the same answer.
then what you're gonna do is you're gonna graph this functions and graph that function, see if they're the same graph.
See, the only difference is negative and positive. Rest everything, my final equation and your final equation is just the same.
Yeah, possibly. I think it's harder to see it that way though. But it's possible they have same answer because sometimes trig integrals they have multiple answers. And
Multiple
yeah, they can have most of integral. Like if you go up to all the integration, like teachers teaching, there will be like 5 ways to do this integrals. So
Yeah.
there's not only one answers. So I'm sorry I told you wrong first. It just sometimes it's harder to see without actually doing it, right? So it's harder to see. So it's much easier to just look at a solution. But yes, now comes to think about it, if you have this tangent square to convert to in terms of secant, then
Yeah.
all you got to do is multiply, then you have to secant. Yeah, it will work. It will work perfectly.
Yeah.
So that one way is you take a picture of this and you graph this function and graph that functions, graph your answer, and you on the decimal see if they come out exactly the same. If you come out exactly the same, they should come out as because the integral you're gonna get exact same graph. So sometimes you're gonna get a different answer. So I'm sorry I told you wrong first place.
Yeah,
But that's a until I start doing it, then I can see what's possible. Yeah, is it possible to have a different way to look at it?
yeah. You just did 1 plus 10 square x and I did secant square negative 1.
Yeah.
Yeah, that's.
Okay. But to be sure, graph on decimal to make sure see if they are a match.